3, 2, 1, go. We are recording. So I will correct those on my prep hour. I corrected one and it looked awesome. Very impressed. All right. So here we go. That's not running right now. It's just recording the screen. All right. So today the plan, polyatomic ion quiz. We did that. And then the next is to get good at naming a formula. So it's sort of the reverse. And I don't remember if we got here at all yesterday. But instead of finding the formula from a name, we're going to find the name from a formula. Sound good enough? All right. If you had chemistry last year, this should be quite a bit easier. That's only 2 of you, so the rest, this might be a little hard. But it is easier than it's easier now that we have done the other half. How about that? So, I didn't look at yours. I only graded Olivia's. So, inorganic nomenclature, that just means naming things that aren't organic molecules. Organic molecules have a whole different set of rules. And they're not bad once you learn them, but they're not that fun either. So the first thing we do is name the cation. So just simply like Al2O3. Just to find the name of that, it says to name the cation, which is aluminum. Just trust me. And then it says, if the anion is an element, is oxygen an element? Yes. Then just name it ending in "ide." Aluminum oxide. That wasn't that bad, right? So what would NaF be? Sodium fluoride. All right. How about MgCl2? Magnesium chloride. What about these 2s and 3s? Don't they matter? Not really. They don't. I got to fix this. This is unacceptable. How do you kids learn in desks that wobble? Struggle. Too far. This is all being recorded. Much better. All right. So that's not hard. All right. The next thing says if the anion is a polyatomic ion, simply write the name of the polyatomic ion. So now if it's AlNO3, we write the name of the cation, which is aluminum. All right. And then we just name this thing nitrate. Now, I'm definitely getting a feeling that some of you just don't care and or plan to memorize the polyatomic ion. So that's fine, but you better get used to liking fluorine because that's what your grade's going to be on this test. If you don't know what the polyatomic ions are. Go ahead. Thank you, Lloyd. I'm not talking to everyone. But you need to know these because you can't name aluminum nitrate if you don't know what NO3's name is. Okay? Let's do a couple more here. What if I have Na3, PO4? Tell your lab partner what the name of this is. All right, sodium phosphate. Who had that? Not bad. Okay? As long as you know your polyatomic ions, this is pretty easy. All right. Then, this should be like a star, a flag, like a red flag or something. This last part. If the cation can have more than one possible charge, aka it's a transition metal, write the charge as a Roman numeral in parentheses. So this is the only time that this is actually sort of hard. So if I draw my periodic table, please remember your transition metals live pretty much right here. All right, these are your transition metals. They're ones that we don't know what the charge is, so I have to state what the charge is. All right, yep, except for zinc, cadmium, and silver, we do know. So for instance, what we're looking at would be something like Fe2O3. Now, most people call this rust, but that's not its chemical name. So, basic rules would tell us this is iron oxide, right? And for most of the world, that's good enough, but not in this class. It's not iron oxide. Because iron is a transition metal that can have more than one charge. So what we have to do, there's two ways to do this. One is easy and gets you the right answer 90% of the time. One's a little harder and gets you the right answer 100% of the time. Okay, so sort of your balance on how you want to do this. I'm going to show you the long way. When it's a transition metal, what you do is you write the charge of the anion. That's a -2. This will sound familiar postally in a second. All right? We take the number of the anions and multiply it by the charge. So we take 3 times -2. And what does that equal? -6. Then we're going to divide the absolute value of this number by the number of first atoms, which is a 2, which equals what number? 3. And that is my Roman numeral. Okay, that's the longer and harder way. The easier way is what I call the hop and swap. The hop and swap means the number of atoms becomes the charge of the thing. And that will be right 90% of the time. This process is right 100% of the time. Okay? Man, she's smart, isn't she? It won't be right if you have to reduce it. And that's why oftentimes you really do need to do it the long way. So for instance, if I have SnO2, you may think N is a +2. That's an N. And you might think this is a -1, but that is incorrect. Let's do the process. So I take the charge of the second thing, and I multiply it by the number of second things. -2 times 2 is 4. And that's a negative. I'm just ignoring it because we're always going to take the positive value. Then I divide it by the number of first things, which is 1. So this is 4. So this is 10, 4 oxide. So do you see how it can trick you? Because if you did this, if you just had 10, well, it's right here. Why am I rewriting it? When we went from a name to a formula, we're like, all right, this is Sn, this is O. This tells me this is a +4. This is a -2, and you had 2 and 4, but you have to reduce it, and that's why it became SnO2. Okay? The hop and swap doesn't account for when you reduce it. So just be careful. Just be careful. All right. Want to do another example of that? All right. So chromium and sulfur. The name of that be? Give that a shot real quick. So. Oh, that was stupid. All right, this is pretty much the exact same as we just did. So you can just chuck it. Sulfide is a -2, so 2 times -2 is -4. Well, we just turned that to a positive. Divide it by the number of first atoms, which is a 1. So now that's a 4. Chromium 4 sulfide. Who had that right? Raise your hand. Okay, good. All right, now, never be afraid. That number can be up to 6 sometimes. It usually does not go to 7 or 8, but 6 is pretty common. All right, this one's tricky right here. How about Hg 2O? Take a second and try and do that one. All right, here we go. This one's not too bad, but sometimes kids kind of mess up. How many O's are there? 1. What's its charge? -2. So 1 times -2, just making it positive, is a 2, right? Divide it by the number of first atoms, which is 2. That equals a 1. Mercury 1 oxide. Who had that right? Okay, good. Tierney, I feel bad. Every time we do something important, you're gone. I'm sorry. It's just a hop and swap. It says, hey, this is a 2, so that must be a 1. And that works on this one. It works on most of them. All right, so when in doubt, just take the number here and put it there, the number here and put it there. Fair enough. Yeah, you really have a 90 or better % chance that you're going to be right. Yeah, Lottie? You have to know that from your periodic table. O is right here. It's 2 away from family 8, so it's a -2. Okay. Good? How do we feel so far? All right. What's that? You want to do another one? Okay, I think I have actually. Okay. Maybe I deleted them last hour. Okay, let's do 3. So, I'll just make them up. We're going to names, right? Sorry. Okay, so try and name that one. No, that's not what I want. You're not there anyway. This is what I want.
Is he really?
Yeah.
That's awesome. Like to everyone, just like double D.
The whole school calls him Double D or Big D. So he's fine with that. Okay, moving on.
Either one's good. Yeah. That's so funny.
Magnesium
I wish I had a cool nickname like that.
Nitrate. Who had that right? Raise your hands. You could be. Raise your hand if you got it right. That's all. Yes. Well, it is a charge of 2, but look. Magnesium is always a +2. If it's always the same thing, I don't have to be told what it is. You with me? If we know it's charged, we don't have to say it's charged. It's redundant. Same thing in the next one. This is silver. And silver is always a +1. It's nothing different, so I don't have to be told what it is. I already know it's a 1. And what's the name of this thing? Acetate. All right, they're both negative and positive, so it's just silver acetate. If you acetate, that's fine. If you put the Roman numeral on both of those, it's okay. But now, do you know why you don't? If it's known, you don't have to tell me. Now, down here, chromium is not a known charge, correct? So this one, I made this one tricky on purpose. This one, the hop and swap will not work. So you have to do the long way. So you take 2 and multiply it by the charge of phosphate, which is -3. I'm just going to make it positive. So that's 6. And I divide it by the number of first atoms, which is 1. So that becomes a 6. And that is my Roman numeral. Chromium 6 phosphate. Okay. One last time. No Roman numeral because magnesium is always a 2. No Roman numeral because silver is always a 1. Yes, Roman numeral because chromium is a transition metal that could have anywhere between a +1 and a +7. Okay? So if I don't know it, I have to be told what it is. Okay, what do we think? You okay? All right, good. Thumbs up if you're okay. Okay, that's 85% roughly. All right. We're going to talk about, well, we already did oxyanion nomenclature, right? The 8 hypo or per. Okay, we talked about that. So we're going to talk about how to name acids. If you're a note taker, I put what you should write in bold. These are some things that you definitely write if you're a note taker. Once we talk through this process, it's not awful, but it would be very hard to just figure it out if you hadn't read the book or been taught. Yeah. It's like the process of naming. Oh, all right. That's kind of nice having that little countdown timer. So here we go. First off, what really annoys kids, and I don't know why, because just don't worry about it. Nope. Is in naming of acids, they all start with an H, so we never care about the number of H's. The number of H's is never indicated in the name of an acid, so don't even think about it, consider it, or worry about it. How we name an acid is always determined by the anion. Whatever's here, that's ugly, but I don't care. Whatever's there will determine what the name of the acid is, okay? So look, we're looking at the anion. Don't worry about the H's. So here we go. If, we're going to go through all 3 of these. If the anion in the acid ends in "ide," so once again, we have to know how to name stuff. So if I have HCl, I need to know that the anion of Cl- is named fluoride. Now, this isn't hard. Every nonmetal that's just itself, meaning not a polyatomic. So that's not hard. Nitride, oxide, fluoride, chloride, bromide, iodide, sulfide, seleniumide, phosphides. No, that's not one. We're out. That's it. They all end with IDE if they're alone. Are you okay with that? All right. So if you just come along and you're like, hey, it's chloride, this is the process. I change "ide" to "ic." And then I add the prefix hydro and the suffix, whatever, ending, acid. Hydrochloric acid. Yep. Nope. Yep. Nope. And it seems like it. The hydro is indicating to you that you are just dealing with H and a single element, meaning no polyatomic ion. Now, I know hydro seems to stem from hydrogen. It sort of does, but really it's just telling me it's a binary acid, a 2-piece acid, an H and a nonmetal that ends in "ide." All right? So the next one, hydrobromic acid, Br. Br- is bromide. Bromide becomes bromic. Since it's just an ide, it's hydrobromic acid. Okay? One that is not on this screen would just be H2S. What's the name of just S? Sulfide. So then ide becomes ic. So sulfuric. Hold on, the L and the F. Sulfuric, and then we put a hydro, and then an acid. Okay, now there is sulfuric acid, which looks the same, but it definitely is not the same, and we'll get to that. Okay, Reyes. The 2. You do nothing with the 2, ever, 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 because the hydrogen has nothing to do with the name. Look, 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 look. The hydrogen is always accounted for in the name with this word. Hydrophosphoric acid is a thing. It would be H3P. The polyatomic ions are the next 2 rules. Nope. These are the only ones that have hydro. The rest of them, no hydro. So here we have hydrosulfuric acid. But I'm going to get rid of that and have sulfuric acid in a second, and it's a completely different formula. Yeah, hydro, it's only binary, meaning an H and one other atom. Now, it doesn't matter how many there are, 2 or 4, but 2 types of atoms. Okay. Now, one more time. It's funny, I started this whole conversation with saying that H has nothing to do with it, right? And most of your questions have been like, well, what about the H? The H has nothing to do with it. Let's define real quick, and we have 3 chapters later about dedicated to acids. But hold on, Boyd. An acid is a solution that has excess H plus in it. That's what an acid is. So it would make sense that if I put HCl into something, it makes it become acidic because I'm increasing the amount of H plus. So anytime we have the word acid, I don't need to say anything about H because I know it has H. And chemists don't like to repeat themselves. All right. Now, Boyd. That's the binary acid, yes. The binary, once again, means an H and only one other type of atom. Okay, now, most of our acids are made out of polyatomic ions, so we have to have different rules for those. So the next thing you should add to your notes, and this is a great time, and you probably aren't doing it, but this is a perfect spot for that 2-column notes, to have this rule and then your 3 or 4 examples on the right. If the anion in the acid ends in ATE, change the ending to ic acid. Now look at that carefully. Does it say the word hydro anywhere? No, so don't put it or you'll get it wrong. It just says ic. All right. So here we go. So HClO3. Notice it is not binary anymore because there's 1, 2, 3 types of atoms, which would be tertiary or something like that. So here we go. We have ClO3, which we should know is called chlorate. So it ends in ATE, so I change the ending to ic. So it becomes chloric, and then it just says acid. And I'm done. No hydro, no anything, because we don't care about the H. The H is taken care of with the word acid. Okay? Perchloric comes from perchlorate. Get rid of 8. It becomes ick, and it's perchloric acid. The most common one you are familiar with that's just ick is this, H2SO4. SO4 is called sulfate. Since it's 8, it becomes ick, sulfuric acid. Yeah. Yeah. Sulfuric acid. We all right with that? What would H3PO4 be? Phosphoric. Whoops. It's okay. If you put phosphoric acid, I wouldn't mark it wrong at all. 100% you nailed it. Yeah, there you go. Okay, the final one is if it ends in ITE, we change the ending to OUS. Does it say anything about the prefix hydro? Nope, so do not put it. Because hydro, hold on, I'll stay here. So if I have H2S or H2SO4, that's an S. Both of these are sulfuric acid, but they can't have the same name. So this one gets the prefix hydro. Hydro is your indicator to tell you this thing is not a polyatomic ion, it's just the atom. Yeah, it definitely does. We'll learn all about that. Okay, I wish we had like 2 more minutes. You guys are great, though.